Everyone, this is Richa. A warm welcome to my YouTube channel Math in Depth. Motto of this channel is to focus on giving clear concept in math. And our today's video is based on a theorem, a very well-known theorem. And the name of that theorem is Pythagoras theorem. Now let's understand what this theorem is all about. This theorem is based on a right angle triangle. It basically talks about the relationship between the sides of a right angle triangle. Now this is a right angle triangle and the sides are A, that is a perpendicular line. Another side is B, this is the base line, and the other side is C, that is the hypotenuse of this triangle. Now we will see how these sides are related to each other. Now here what we have done, we have made the square based on the length of the sides of a triangle. Like this is a perpendicular line. So we have made a square based on the length of this perpendicular line. This is the base of a triangle and the side was B. So we have made a square based on the length of the baseline of a triangle. In the same way, this was the hypotenuse and the side was C. Here we have made the square based on the length of the hypotenuse. Fine. Now here what we have done, how it comes a square. Now if this is a square and if you try to find out the area of that square, that area is a square. The same way this is a square based on the length b. So if you find the area of this square, that will be b square. And in the same way this is also a square based on the length c. So if you will find out the area of this square, that will be c square. Now we will see like how this a square, b square and c square are related to each other. Now here what it becomes, that a square plus b square now is becoming c square. It means what it states, that the square of the hypotenuse is equal to the sum of the square of the other two sides. This is Pythagoras theorem. So Pythagoras theorem talks about the relationship between the sides of a triangle, and it says the square of the hypotenuse is equal to sum of the square of other two sides of a right angle triangle. Clear? Now we'll understand the same thing with the help of an example. Now let's take a triangle here. Fine, this is a right angle triangle and the sides of a right angle triangle is A, B and C. So what we will do next, we'll make a square based on the length of the sides of a triangle. So but before that, just understand what is the length of this triangle. Length of this baseline of a triangle, that is 3 centimeter. Length of this perpendicular line is 4 centimeter and the length of this hypotenuse is 5 centimeter. Fine. These are the length of the sides of a triangle. And what Pythagoras theorem talks about? Pythagoras theorem says that a square plus b square is equal to c square. It means the square of the hypotenuse is equal to the sum of the square of the other two sides of a triangle. Fine. Now again what we will do here? We'll make the square. We'll make a square which is based on the length of this perpendicular line. Okay. Again the same way we'll make a square based on the length of the baseline of this triangle. Again we'll make a square that is based on the hypotenuse, length of the hypotenuse of this triangle, that is C. Okay. Now if we'll try to find out the area of this square, what it will be. This is area of a square based on this length. Here A is equal to 3 centimeter. So the area of this square, it will be 9 centimeter square. Okay, we know that area of any square is the length of the sides square. Whatever the side is there, the square of that side, that will be the area of that square. Fine. So here area of this square will be 9 centimeter square. In the same way, area of this square, it should be 16 centimeter square. Okay, it's a 16 centimeter square. Now what we'll do, if we'll add up this 16 plus 9, what we are going to get? We are going to get 25 centimeter. Fine. 9 plus 16, it will be 25. And here if we'll square this, 5 centimeter also, we will get 25 centimeter square. Okay, now you understood that if we are adding up the square of the length of the two sides of a triangle, it's equal to the square of the hypotenuse of that triangle. Okay, here also we can make like this 9 plus 16 is equal to 25 centimeters square. Okay, you can try with different length of the triangle and check it that it's working or not. Fine, so till here it's understood. Now we'll try to understand little more about this Pythagoras theorem. Um, Now guess who is this person? He is a Greek philosopher and a mathematician. Yes, his name is Pythagoras and he was a great Greek philosopher and a mathematician. He was a person who had introduced this theorem to the world around 1900 BC. Okay, he introduced this theorem around 1900 BC. And after 1900 BC, many mathematicians took interest in this theorem and tried to prove this theorem in their own way. That's why currently we have various ways to prove this theorem. Fine. Now some of the ways are the following are the some of the ways, because we have right now various ways to prove this theorem. Here we have mentioned only some of the ways through which these theorems can be proved. Okay, and what all that ways are? First one is rearrangement proof, algebraic proof, Einstein proof by dissection without rearrangement, Euclid proof, proof by dissections and rearrangement, proof by area preserving shearing, other algebraic proofs, proofs using differentials, and proof using similar triangles. Now we are also going to prove this theorem using this method, proof using similar triangle, and we will also try to prove this theorem. Fine. Okay. Now here, what is this theorem? This theorem, now we know already that the square of the hypotenuse is equal to the sum of the square of the other two sides. Okay. So let's take a triangle. Fine. So this is a right angle triangle and this triangle is ABC. So what we need to prove here? AB square plus BC square is equal to AC square. This is the AB, this is the baseline and that is the BC, and this is the hypotenuse, that is the AC. Okay. So we need to prove here that AB square plus BC square is equal to AC square. Okay. So how are we going to prove this? Can we do some construction? Can we do some construction on this triangle? Yes, we'll do some construction on this triangle and then we will try to prove this theorem. So what kind of construction we can do here? Let's draw a perpendicular line BD to AC. Fine. So what we will do here? We will draw a perpendicular line from BD to AC. Then this is a perpendicular line BD to AC. This is perpendicular means this is 90 degree. Okay. Now what we have here, earlier we were having only one triangle. Now we have three triangle. One triangle is ADB. Okay. The second triangle is B. The second triangle is BDC. Okay. This is, and the third triangle is ABC. Okay, that original one. Okay, now can we write here? We have triangle ADB, BDC and ABC. We'll write like this. Okay, now among these three triangle, first we'll take two triangle. Okay, like triangle ADB and triangle ABC. Okay, and we'll try to prove that these two triangles are similar to each other. Why? Because we are going to use the similar triangle theorem to prove this part. That's why we are trying to prove these two triangles first here, the similar triangle. Okay, now uh, let's delete all this part. Now this triangle, you see this A, D, B and triangle A, B, C. Okay, these two triangle, angle A. Angle A is common for both the triangle. In triangle ADB and in triangle ABC also. Triangle A is common here. So angle A is a common angle. Fine. And the second part you can notice this angle D. Angle D of this triangle ADB. This ADB, this triangle D is 90 degree. Fine. And in triangle ABC, this triangle ABC, the original one, in triangle ABC, this triangle is also here, the angle is 90 degree. Okay. So we have angle B is equal to angle D. Angle D, why? Because it's 90 degree. Okay. Now two angles are equal in both the triangles. Now again, if you notice in triangle AD, in triangle ADB, this AB is common. So many lines. Let's delete this first. Okay. Now in triangle ADB, okay, this triangle ADB, this AD, sorry, this AB, and in triangle ABC, in triangle ABC, here also AB is there. Fine. So this AB is common for both the triangle. So can we write it here like this? Angle A is equal to angle A, y is common and side B is a common. Okay. So two angles are equal here of both the triangles. And again angle ADB is equal to angle ABC, y is 90 degree. Angle ADB is equal to angle ABC because both are 90 degree. So these two triangles, so these two angles are equal. Now these two triangles are similar to each other by AAS congruence. Okay. Now do you understand how these two triangles are similar to each other? Because of AAS congruence. Now what is AAS congruence? There are many theorems which is based on the similar triangle, which I have already uploaded the video of that similar triangle theorem, and I'll post the link of these theorems in the description of this video. Fine, you can check it there for better understanding. But here I'll just let you know what is this AS congruence so that you have the better clarity. Okay, fine. Now if we have two triangle, okay, if we have two triangle, okay, and we want to prove these two triangles are similar to each other, so there are some ways. Okay, there are some ways. What all the ways through which we can prove these two triangles are similar? The first one is AAS. AAS congruence. Now what is this AAS? AAS means two angle of that triangle should be equal, and any one sides of that triangle, any one sides of that triangle should be equal. Then with the property AS congruence we can say these two triangles are similar to each other. Fine. The second way is SAS. SAS is any two sides of these triangles are equal. Any two sides of these triangles are equal, and at least one angle of these triangles are equal. Then also we can say these two triangles are similar to each other. Okay, then we can say SA on based on the SAS congruence, these two triangles are similar to each other. The third one is AAA congruence. What is this? Means all the angle of these triangles are same, then these two triangles are also similar. And the fourth one is SAS SSS congruence. Means all the if all the sides of these triangles are same, then also these two triangles are similar. So these are the theorems. uh, I have I will post this video in the link, so you can just go through that video. You will have a better understanding about the theorem which is based on the similar triangle. Fine. So here we have used this one, AS congruence, and we have proved that triangle ADB and ABC are similar to each other. Clear? Okay. Now we had three triangles here, and we have taken only two triangles, and we have proved that these two triangles are similar to each other. Now again we will take the another two triangle. Which is another two triangle? The another two triangle is this one, BDC. Fine. This is the another two triangle. This is BDC. Okay. And the original triangle. Which is the original triangle? This is the original triangle A, B, and this C. This is the original triangle. Okay. Now we will take these two triangles, and again we will try to prove these two triangles are similar. Okay. So in these two triangles, this triangle and this bigger triangle, you notice one part, that this angle C is common. This angle C is common in both the triangle. So here angle C is common. Okay. And this is the baseline. This is the BC. BC is the baseline of this triangle BDC. Okay. And BC is also the baseline of this triangle ABC. Okay. So this line is also common in both the triangle. So we can write here like BC is also common. Fine. And you can see here this angle, when it says 90 degree. Why? Because this was the perpendicular line on this line. So BD was since the BD was perpendicular line, this was 90-degree angle, and here ABC was the right angle triangle. So this angle is also here 90 degree. So again two angles are equal. Angle B is equal to angle D. Okay. Why? Because of 90 degree. So again this is the angle, this is the angle, two angle, and this is one side. So by AS congruence again we can say this triangle is similar to this, the bigger triangle, that's the original triangle, and we can write it here like this. Similarly, no need to prove again the same part. In the exams you can write directly like this. When you are going to prove this theorem, you can write directly. Similarly, triangle BDC is similar to triangle ABC. Okay. In bracket you can write it here as congruence. Okay. So right now what we have proved that ADB is similar to ABC and BDC is similar to ABC. Okay. Both the smaller triangle here are similar to this bigger original triangles. Now can we write here, if this triangle is similar to this bigger triangle, again if this triangle BDC is similar to ABC, so can we say ADB is similar to BDC? We can say it now, because both the right side are same here. So this triangle automatically here ADB will be also similar to triangle BDC. Okay. And we can write here, and we can write it here like this. From 1 and 2, triangle ADB is similar to triangle BDC. Fine. So till now what we supposed to prove? We supposed to prove here AB plus BC is equal to ACA square. Okay, and we have what we have done till now. We have taken the three triangle after drawing a perpendicular line BD on AC, and we have proved that all three triangles are similar to each other. Okay, all three triangles are similar to each other. Now next, what we will do here, we will take the two triangle which we have already proved the similar to each other. We have taken here two triangle and these two triangles are similar to each other. Now if we have two triangle, like if we have two similar triangle, so there are some properties are there. Like if two triangles are like similar, then the corresponding angle, corresponding angles are equal. Okay, this one, and corresponding sides are in the same ratio or in same proportion. Sides are in same ratio. Fine, this is the two properties of a similar triangle. Okay, so we are going to use these two properties here and we will try to prove that theorem by using these two properties of that similar triangle. Okay, so here what we have done here, I said already the sides, corresponding sides are in the same ratio. So we have taken here ADB and ABC. This is the triangle ADB. This triangle we have taken here, this triangle, okay, and the bigger triangle and the big size triangle ABC. Sorry, my straight lines are not going straight here. Okay, these two triangle we have taken, this one and this bigger one. Okay. Now in this triangle, look at this smaller triangle. This smaller triangle, we have taken this line AD. If this is a triangle ADB, this is the, I'll delete something. In triangle ADB, okay, this is the triangle ADB. This AD is the perpendicular line. This BD is the baseline, okay, and this AB is the hypotenuse. Fine, and it's this big size triangle, that the bigger triangle ABC, okay, this is the baseline, okay, and this line is the perpendicular line, and this line, this AC is the hypotenuse. Okay, this is the big size H. Okay, now we have taken this AD. In triangle ADB, we have taken AD, that perpendicular line. Okay, AD. And in the big size triangle ABC, we have taken AB, perpendicular line. Now both perpendicular line only we have taken. Why? Because I said if two triangles are similar to each other, the corresponding sides are in the same ratio. What I said? Corresponding corresponding sides are in same ratio. Okay, that's why we are taking the same kind of sides. So corresponding side AD, here we have taken the perpendicular line. So in ABC also we will take a perpendicular line. So AD by AB, that will be equal to AB, this line, this ADB triangle, this is the hypotenuse. AB is the hypotenuse here. Fine. So we'll take here the hypotenuse of the smaller triangle. Okay. And the hypotenuse of the bigger triangle is AC. Hypotenuse of the bigger triangle is AC. So these two corresponding sides are in the same ratio. Fine. These are the properties of a similar triangle. So can we move this like next step? We can take AB here and AC here. Can we do this part? Okay. So if we are doing this, it will become AD into AC because this AC came here. Okay. and AB into AB, because this AB came here. Okay, AD into AC, AB into AC. Now AB into AB, what it will become? It will become AB square. So here we have got one, like we will mark it as a third number. First two number we have already done. So this is the third number, third equation. AD into AC is equal to AB square. Okay. Now again we will take the other two triangle which we have proved that two triangles are similar. Which two triangle we will take now? Now we will take this triangle, this one, the smaller size, this BDC. Okay, this is the smaller triangle BDC we will take, and we will take, this is the original triangle ABC. Okay, this is the original triangle ABC. So this we will take, this one and this one. Fine. So again we have taken these two triangle BDC and ABC, and we have already proved that these two triangles are similar to each other. Okay, so if these two triangles are similar, then what is the properties? Like here also same way we can write it, the corresponding sides are in the same ratio. So which side we are going to take? First, this is the triangle BDC. In BDC, this is the baseline. Okay, this is the baseline, this is the perpendicular line, and this is the hypotenuse. Okay, and in the bigger size triangle, the original triangle, you know, this is the sorry, this is the perpendicular line, this is the perpendicular line, this one is the baseline, and this one is the hypotenuse. Okay, this is the hypotenuse, this is the perpendicular line, and this is the baseline for the big size triangle, and this is small triangle BDC, this is the perpendicular, this is the baseline, and this is the hypotenuse. Fine. Now here what we will take? We will take the baseline. Okay. So let's see. We will take here baseline CD. This is the baseline CD of a small triangle, and the baseline of a big triangle is BC. You can write it here. We have taken CD. We have taken here CD. Sorry, my writing is not good. CD, and then we have taken the BC. Okay. And another one we will take here, the hypotenuse of this smaller triangle. Hypotenuse of this smaller triangle, what is this? This is BC. BC is the hypotenuse of the smaller triangle. So we will take here BC, and hypotenuse of the bigger size triangle is AC. We know it. Okay. So we have taken like this. Now this can go here and this can go here. Fine. This so can we write it here now? CD into AC is equal to BC into BC. Why? Because this BC has came here and this AC has gone there. Okay. So it becomes CD into AC is equal to BC into BC. Now BC into BC, what it will become? It will become BC square. Fine. Now here we have two equation. Okay. Now here we have two equation. This is the one and this is the another one. Okay, what we will do here, we will add both the equation, we will add it here. So add 3 and 4, write it, add 3 and 4, and then we can write it like this: AD into AC, this is the AD into AC, CD plus sign, this is CD into AC, CD into AC. Okay, and this right hand side is AB square. Here AB square we have taken, and BC square, here BC square we have taken. Now again to simplify this, we'll delete the, sorry, delete this part. Now to simplify this, what we can do, here? This is, we can take AC common. We have taken AC common, and it will be AD plus CD. Okay. Here is also AC is there. Here also AC is there. So we have taken this part common. Now it's become AD plus CD. Okay. Now AD plus CD. This is AD plus this is CD. So AD plus CD, what it will become? It will become AB. Okay. Sorry, it will become AC. Now here we have AC, it was there, or after adding this also became the AC. So now this AC into AC, what it will become? It will become AC square. Okay. AC square plus is equal to AB square plus BC square. It means we have proved here AB square plus BC square is equal to AC square. Okay. What we supposed to prove here? We supposed to prove this part. AB plus BC is equal to AC square. And we have proved it. AB plus BC is equal to AC square. Then our theorem is proved there. Okay. So I hope this video would have helped you to understand this theorem. Okay. And if you found this video helpful, please give it a thumbs up and subscribe to our channel so that we can watch more content like this. Fine. Thank you. Thank you so much for watching this video. Thanks a lot. Thank you.